Okay, and then I'll change to the presentation mode. Just 1 minute. Okay. Okay, and so you should be able to see the slides. Can you?
Yes, Professor.
Yeah. Okay, thank you. And okay, and this week we're going to talk about and task abstraction. And so if you remember from last week, we'll talk about and whether a visualization is good or not is not depends on say how beautiful or flash or colorful the visualization is, but rather say whether that matches the task that you want to address. Okay, so I'm going to talk about different type of tasks today, and but first we'll do a quick kind of review of what we covered the last week. Let me see how to put this. Okay, and so last week we talked about what is data visualization, and there's a few things we want to emphasize. So first, and the visualization is to augment human capabilities, not to replace people. So you still need the people in the kind of an analysis or decision-making process, and the visualization will help, but not to replace the human. And then, so one of the main advantages of visualization is using external representation so that you can replace cognition with perception in the sense, and you don't have to imagine what the data looks like. You can just look at it, which is much easier for us human to process the information. And we choose visual instead of other and senses. For example, we didn't use sound or smell, and because visual system has much higher bandwidth compared to other channels of sense we have, so we can process information much faster. Okay, and then this is kind of what we will cover or talk more about and today. And we're talking about say whether a visualization is good or not. It depends on whether it's suitable for particular tasks. So there's no one visualization can serve all different tasks. So when it's working well for one task, might not be so well for the other tasks. So even for the exact same data sets, we might have many different visualizations just for different tasks. Okay, and that's the last point. And in terms of there's limitations in terms of how much and can be visualized. And the first one is the limitation of the computer in terms of how much memory or how fast it can process. And the second one is the limitation of the display in terms of how much you can physically put onto a display, in the sense how many pixels you can have on the display. And finally is the limitations of humans. We add human, if you give too much information, we'll be easily overwhelmed, will not be able to make sense what's being presented. So this is usually the most limiting factor, in the sense we might only be able to see a few hundred or maybe up to 1,000 items. Ah, okay. And I have a message from Zohab. It says or she seems to
Yeah,
come.
I'm not able to see any
So, but we
slides.
can see, so we can see.
Okay. So it looks like everyone else can see at least some people can see. So you might have to check. I'm not sure exactly. And so I think the other thing you can do is just download the slides. The slides are on the module page. If you can't see my screen, just download the slides and follow on with the slides. Hopefully, I can figure out which slides we are on.
Okay, no problem, sir.
Yeah. And okay. And also we covered last week is about these different concepts. Okay, and there's a lot of concepts that can start get quite confusing. And so first we talk about different data types, and we talk about items and attributes. And So I guess maybe it's better to look at in the context of the table. The table itself is a data set type, and you have the row, which is like items, and the columns is like attributes. And then you have the links, which only exist in the network type of data set type. And so each node is items, and there's links connect them. So that's the links. And then we have the positions, which is more relevant in this geometry dataset type. So again, you have the items, which are each individual dots, and then you can have the where they are in the map. So that's the position. And then finally, there's grids. Grid, we didn't really talk too much about it, and it's in the data set, which is called fields. So that's mostly for, say, 3D models of the human brain scan, for example, and which we will not cover. And in this module, we just mentioned here for completeness. Okay, so that we covered both the data set types and the data types. And then one of the data type is called attributes. So these are the columns in a table. And so if you imagine, so that's the information about products in the supermarket. So the attributes are like the price, the name, the category of the product. And then the attribute itself has different types. And because that's the part usually is the part most you'll be visualized or be focused on, visualization will be focusing on. And you can have categorical type. And in the sense, you can only tell they are different, but you cannot say order them or do any computation. The examples, for example, again, taking the product. So you can have product name. So you can say whether they are same product or different product, but you cannot really say order the names in some order, or you cannot say take one name plus the another name and get the third name. That doesn't really make sense. So that's categorical. And then we have ordered attribute type, which further divided into ordinal and quantitative. So both of these can have order. So you can have a dress size, which can have small, medium, large, and you can have the price for a product, and you can have 1, 2, and 2.5, etc. And then the difference between these two is the ordinal. For the ordinal, you cannot do any computation, so you cannot take a small dress size plus a medium dress size. It doesn't really give you anything. Whereas in the quantitative one, and these are numbers, so you can do all sorts of computation. You can do addition, minus, or average, etc., etc. Okay, and these are the ones we didn't quite talk about. Okay, and yeah, so that's a very quick overview of what we covered last week. Um, okay, so this week we're gonna cover mostly two things: an analysis framework. So that's like the general idea, which actually covers everything in the book, and then the task abstraction, which is part of the analysis framework. And then after that, if we have more time, we'll show some and a bit more doing visualizations in Tableau. Okay, and I mean the analysis framework itself might sounds like a quite grand term, but it's relatively quite straightforward. It has three parts, which is what, why, and how. So it gives you a way to think about how do you find the best visual design and for a particular task and a data set. Okay, and the general idea of finding a good design is, let's imagine this is a space of all the possible visual designs for the task you have at hand. And in general, you want to start with a quite broad, cover as much as you can, and then starting try to narrow down until eventually maybe you find the best ones. And so it's a little bit dangerous to start with a preconceived idea. So you think, okay, this visualization, sorry, and this task is best suited for a bar chart. And then you look at different variations of bar chart to finally pick the one. So this way you start with a limited design options, and you might miss the best ones, and in the end you may find the better ones among your own space, but that not be the best one among all the possibilities. Okay, and so this is an kind of the three main parts of this so-called analysis framework. And the what is about the data, and so the data you need to analyze, and the why is the task, and what user want to find from the visualization, and then depends on the task. You will need to create different visualizations. Here we're providing a kind of general task abstraction, and so then you'll be able to come up with different visualization guidelines and without particularly domain, and we're going to talk about that in a minute. And then finally is the how, and the how is just exactly the actual visual design. So after considering the data types and the task types, you might come up with certain visual design which would meet these two requirements. And we will provide some existing kind of guidelines. And in the book or the lecture, we're going to call them idioms. In the sense, these are not strict rules. Instead, these are guidelines. They work based on people's experience, and they work most of the time, but not absolutely every time. So you need to know what these are, but not you have to be flexible as well because they might not work in certain cases. Okay, and so we already covered this part, and this basically is and the what of the framework. We said there's three parts: the what, why, and how. And the what, it just talk about different types of data, which we already covered. What we covered in terms of the different types of data or data set or attributes, we haven't quite talked about, say, if it's table data, how do we visualize it? If it's network, how do we visualize it? And this will be the how part, which will come later. This is the second part, which is the why. And again, so this is actually what we're going to cover today. Again, there's quite a few different tasks. So in general, it's just abstracting the different tasks you might need to do for visualization. I mean, you can imagine there are many different type of possible tasks you can do visualization. So here, and that's why there are so many different options here. And we're going to go through this hopefully in this lecture. And once we go through both the what and why, basically after this week, we'll start going to the how part. And the how part tells you how to visualize and different types and certain idioms or guidelines when you design the visualization for different tasks and so on and so forth. So that's basically the rest of the kind of the first half of the module. We're going to talk about how and exactly how to design for different and data and analysis task. Okay, so that is like a quick overview of the analysis task. And obviously we have covered the what part. And today we're going to talk a little bit more about the second part, which is why. And in the other words, it's also called task abstraction. And so first we just talk about very briefly, so why do we want to analyze task and abstractly? So this is what the framework wants you to do. And here, the abstract means you do not rather think of the task as a domain-specific way. So for example, and there's for each domain, they will have some maybe domain-specific tasks, and like, I don't know, maybe in finance or in medical research and in university data, etc., etc. These different domains, they might have different tasks, But if you sync tasks in the specific context of domain, there will be too many tasks. We will not be able to, say, categorize them quite easily. And so what you want to try to achieve is you think about the similarities of we focus on the similarities between the tasks across domains. And so, for example, and maybe one common tasks, and regardless of which domain is detecting outliers, is to find out what are the odd data points in your collections. So in a sense, and finding outliers itself and is an abstract task. It's not dependent on particular domain, and it does not have to be saying finance, business, or say transport, but likely to apply to many different domains. So we can design a method or a way to present data to show outliers, and then that method can be quite useful because it can be applied to any domains or problems that you have, which requires to looking for outliers. Okay. Um, okay, so now before we actually talk about the different tasks, I just want to go back to this slides very quickly. So, I jumped one more. So this is kind of overview of the why, what we'll cover today. We're going to first talk about the actions. So the action is, how do I say, the action you need to do when you try to do the visual analysis. Yeah, so for example, you need to analyze, which is action, you need to search and query. So these are I can't really think of a different words, actions you need to do when you do the visual analysis. And on this part is the target and is the things that you want to find. So you can find that maybe want to find a trend, and you might want to find extreme values, and say example for a network and the specific type of network connection patterns which are which are unique to network data. But overall, on this side is the type of things you want to find. So these are the things you will do, and this is the things you want to find. So those two forms the overall why. So it depends on what you want to do and what you want to find, you will be able to and pick the best visualizations. But first, and you need to pick the action and target and use that to decide on the visualization itself. Okay, and so we will have examples and we can see later on. Actually, maybe I can. Oh, okay, and let's just start with the actions. And this is the same as before. And this was like the left part and of the previous slides. Okay, and so this is kind of like a taxonomy or ontology, if that makes any sense. You actually have three levels. And so at the top level, and you would have analyze. And then analyze itself can be further breakdown into and consume, produce, and consume itself can be further breakdown into discover, present, and enjoy, which we're going to talk a little bit more. Okay, and then the search is the media and kind of intermediate level or middle level. In the sense, this will be the kind of top level tasks or actions you need to do, and most of them will be involve search, but there's different types of searches. That's the middle one. And finally, you have queries. So this is, say, for each particular search, the things you're looking for in those search. And yeah. And the only one thing I want to emphasize here is, and later on, for example, when you look at different type of search, these are particular terms that are defined in a specific context. So they will be a bit different and then the normal English meaning of the word. So you really need to so at least for this module or the lectures or the coursework, you need to use the words in the particularly meaning or context we defined as we do in the lectures or the book. And similarly here. Maybe I'll talk more about that later on when we get there. Okay, and we're gonna start with the top one, the analyze. Usually this is the most high level one, and it can be called analyze. Sorry, it's as either an consume or produce. And consume means you are not creating new information, you are just analyzing existing ones. So, and you might be trying to discover something, and and I think that's probably straightforward, and potentially will be presenting something. So this is when you finish your visual data analysis, you already have the results. You want to show the results to someone else, and then your goal there is not to discover something new anymore. You just want to pass the knowledge to someone or share the knowledge with someone else. And there's some cases actually just called enjoy, in which case this is not for business purpose or serious purpose, and it is for personal enjoyment. We're going to see some examples later of that. And for discover, so that's usually what we, maybe most common one. You want to analyze the data, you want to discover something new you don't know before from the data set. And it could be something completely unexpected, or you might have some idea about the dataset already, and you use Discover or the visual analysis to confirm whether that's the case or not. And so there are two possible goals here, and you either help you to come up with new questions to ask, or that's called the generate, or the verifying means you already have some idea, you just want to confirm if that's the case or not. For example, you might think, okay, and the price of the product increased and continuously over the time. Maybe that's your hypothesis, and you can use visualizations to confirm or disprove that. Or maybe you have no idea, and for example, yes, when we do the car dataset analysis, you might not have any idea of and what are the patterns or findings in the data. Then you can use visualizations to visualize the data, help you generate some hypotheses. Or maybe you have some ideas saying, okay, I think maybe if the car is heavier, then it will be less fuel efficient. Then you have some idea already. Then you can use visualization to verify to see if that's correct or not. Okay, and the second part is the consume. And as I mentioned before, this is when you already find the information and you need to share or present it. So this is like and the exercise, and you need to prepare your PowerPoint slides to show the findings you discovered. So that's what the present is. And sometimes it's almost like telling a story from the data, and so it contains multiple visualizations instead of just one. Okay, and this is very common, especially in business settings. For example, you made a decision based on, say, data analysis, and you want to say that your manager knows what the decision is, but they probably want to know how do you come up with a conclusion why they could trust you on that decision. So you need to present not only the results but also the process as well. Yeah, and I think we already talked about this already. And the present happens when you already know something. You just want to share the information or knowledge to someone else. Okay. And so this is something, and quite often, and something called an infographics, and it's like say part of data visualization. And one thing quite unique is usually it's static. It's not something you can interact with. So for example, it does not, if you click something on that, it usually doesn't change. And infographics is usually designed to give you some information about a particular topic. And so this is not really about any particular topic. It's just what the infographics could look like. It has lots of numbers or facts about a particular topic, and they use the graphics to help people get the information. And it's usually easier than just have text and numbers for people to understand. And okay, and the last type of consume is enjoy. So as I said, it's usually just for personal consumption or personal entertainment, and it's not really for any serious and say purpose. Okay, and probably easier just to look at some examples. I think I would have example later on called here. Uh, okay, so and this particular example, the name of the visualization is called name Voyager. And so all that does is it shows the popularity of different first names over time. So obviously this is only for English. And so as you can see here, and in this particular case, and the user choose the name which start with letter O. So here it's only show the name start with O. And then on the x-axis is the time. So you start from the 1880s. I'm not sure, the text might be very small, all the way to 2012. And the y-axis shows the popularity, how common the name is, how many times it has been used. And then here, again, it's very small. Later on, I'm going to see a real example. You can see these are the different names. For example, this one name is called Olive, and this is one is Ollie, and there's Aura. And these names are obviously quite popular in the late 1880s, becomes much less popular in the 1960s, and now come back here. Some names becomes much unpopular again. So each of these kind of band is one name, and the how high the band is shows how popular the name is. If I just click this one again, okay. Okay, and can you see the browser?
Yes, Professor.
Okay, and so this is the actual website of the name Voyager, and so these are all the different names you have, and starting from the 1880s always to 2019, and then this is how popular they are, and this is just relatively, and obviously there's lots of names there. You can choose either boys or girls name, or you can choose and you can filter the names by typing something here. So for example, I can type in name K, and then it shows what are the most popular names over time, and you can see this one, and it's named Karen. So kind of starting becomes to use in here. If you mouse over, it shows you some extra details. It says in the year 1930s, ranked as the number 689th most popular name. So obviously not that popular. That's roughly when that name starting to becomes used and becomes more popular over time. Maybe here is the most popular one. In the 1950s becomes 12th most popular, and then it reduces. Okay, and so that's just one realization. And if we come back to the slides, so obviously this is not used for any particularly serious business purpose or medical or any say police investigations, and people just use it really for fun. And that's actually there's more than this example is okay. Actually, now lots of people are actually using that and to analyze the trend, but mostly just for their own enjoyment. That's the example of enjoy. Okay, and so that's the the three types of consume in Analyze. In the sense, all these cases you do not really produce anything, and so you just look at the visualization either to discover something or to learn something, to present, or just for your own personal entertainment. And then we're going to talk about produce, where you actually need to generate something new. Okay, and then okay, and the first example of produce is annotate, and you add a little bit extra information to, for example, the visualization. And in these examples, we you shows some data of different countries, and you add this kind of notes to in your visualization. It says Turkey, and Turkey is losing money, for example. So this is something you add onto the visualization. You created something new. So that's called annotate. Okay. And another way to create something new when you try to do the visual analysis is just record. That means you save or capture the visualization states, for example, and you can do things like a screenshot, or you can bookmark certain elements or locations, and depends on the support that provided by the tool itself. And sometimes it's just like interaction logs, which is generated automatically by the software. So these are all things generated as you performing the visual analysis. Okay, and so the difference in terms between the annotation and the record, which we just saw before, and record is just save it, what you currently have, and which does not change the visualization itself, whereas as annotation or to add or change something to the visualization. And then the annotation itself can become part of the record, can be captured as well. So, and again, maybe easier to understand is using the and the Tableau example. And so this is not available in the official and Tableau software, and but it's kind of users people did research using Tableau. You can actually and show the graphical history of Tableau. And so what they did is they captured each steps people did when they are analyzing the data. So they start by say loading the data, loading a table into the Tableau, and then this is maybe the automated generated model or the visualization by the Tableau, and then user customize the visualizations to different representations and use them to fit better with their analysis tasks or the data set. And this entire process is captured as a record, and they called it graphical history. So this is actually can be useful for the people to look back on, so for all and to understand, either for the people doing the analysis or other people to understand what happened, and they might go back to a previous state and then say doing something different from there. Okay, and there's a more fancy terms, and it's called analytical provenance, and which is essentially something very similar. Okay, and okay, and I have a question in the chat from Zohab, and says we'll need to demonstrate, annotate, record, and deliver in our upcoming courseworks. And so the answer is no. And later on in the coursework, you need to identify if you have record or annotate. If you use those in your data visualization, but there is not a particularly requirement, say you have to have these and create it in your visualization. Okay, then we'll have to do the last one. Is called Derive, and here is about, again, it's slightly different, but you're also still creating something new, and so it is quite common. Essentially, you creating new information from what you already have in the data. And for example, you have in your data, and you have a value which is a water temperature, and you can convert that into different kind of categories, either hot, warm, or cold. So the hot, and whether the, say, the water temperature is hot or warm or cold, that information is not directly available in the original data. That's something you derived from the data you have. So that's one example. And this is like new attributes, so that these are called derived attributes. And again, so for example, and if in the data set you have the city name, then you can get longitude, latitude information of that particular city. Again, this information, the location information, is not directly in the data set. You need to derive them. And also you can do some calculation, for example, and you can calculate mean and average, minimum, maximum. These are simple calculations, but say that's not a value in the data originally, something you derived. Okay, I'm going to show you another example of derived data. And let's say in the original data, you have the values of imports and exports of a country, let's say UK or India or any other country, and how that changes over time. Let's say this is time, and this is amount of these two. But sometimes maybe that is not that interesting, but this might be more useful for the particular task you're looking at. So instead of showing two separate values, and you show the difference of the exports and imports. So that shows the trade balance and how that changes over time. So the trade balance itself is a derived new attribute. It does not exist in the original data set, and it's derived by export minus import. And if your analysis task is concerning something related to trade balance, and this is probably the best way to look at it. Then say look at these two separate values as two different lines. And okay, and so now we kind of covered all the different type of analyze. And as we mentioned, we tried to cover all the possibilities. So there's quite different options, but for the analyze, and we'll divide it into consume and produce. The difference will be produce, you're creating something new as well. Whereas consume, you just look at the visualization and for different purposes. And each of them have different subtypes, which we covered. So now we're going to move on to the next part, and which is called search. So if you remember, and you probably don't because we have been introducing so many things in a short period of time. So search is the one level below analyze, in the sense, and for all the analyze, it's most likely to involve some type of search. For example, when you try to discover something, you might need to do some search, but also, and when you even doing produce, after you're creating something and in the visualization, it might still involve some search. Okay, and we're going to explain that and what that means. And the first thing is to remember the search is a little bit different from the search in as a English word what it means. So if we talk about search in the general context, people probably think of as, say, Google search, and you're searching for something. And it's not always the case here in the visualization, and in sometimes it is the same. For example, when you do Google search, you usually always know what you are searching for. And if you don't know what you are searching for, it's quite difficult to use a tool such as Google search. And that's one of the kind of aspect when you consider different type of search, is whether do you know the things you are looking for or not. That's the target here. So it says target known and target unknown. And because this is a visualization, so we have another different aspect, which is the position of the target in the visualization, which is called location. And so you might know the location and you might not know the location. And so it depends on these two conditions, then you end up with these 4 different combinations or 4 type of search. And so you potentially can do a search where you know the target and know where that is. And you probably will be able to find the target very quickly. Again, it's always in the context of validation, but there's also a chance you might not know what you're looking for. So you don't know what the target is, and you don't know where that is in the validation, and it definitely takes longer time to find it, and it has a specific name just for this type of search. Okay. Okay, and then here, as I mentioned before, one thing is to make sure you just treat these words as very specific meanings in this context of search in data validation. You cannot just say treat lookup or locate as a general English word. Then when you try to identify the correct type, you'll be very confused. They are only defined depends on whether the target is known and whether the location is known. Okay, and again, we're going to have a look of these for each individual types with example. And so first one, we do a lookup, and the example will be find the vice chancellor, which is like the boss or the CEO of the university, and in the university organization chart. And so this is what organization chart look like. So each box represents a position or a person, and then one person is connected to other persons he manages. Okay, and in terms of the vice chancellor in the university organization chart, you know who you are looking for. You're looking for vice chancellor, so that's your target. In this case, I know who I'm looking for, or the target, or the particular piece of information, or the target, and the data items actually. And you roughly know where the vice chancellor will be in the organization chart, because vice chancellor is like the CEO of the university. It's most likely someone in the top part of the visualization. It's unlikely say the vice chancellor will be here, here, or here. Most likely to be either here or somewhere here. That would be the vice chancellor. So in that sense, you also know the location of the target in the visualization. Maybe not exact at XY positions, but you know roughly where that target will be, and that becomes the lookup. Okay, and so this is one type of search, and if you know your visualization is mostly designed to support lookup, and so then in terms of visualizations, you just to make sure, for example, the labels of the different boxes are quite easy to see, and the people can easily locate this. Maybe the other thing might be useful is if you can turn your search into a lookup, that will be easier for the people who look at the visualizations to find the information. And because in this case, both the target and location is known, and it's usually much easier to find the target in the visualization. Okay, and then the second one will be is example is called the locate, which is this one here. In this case, you know the target, but you don't know where the location that is. So you don't know where that person would appear up in the organization chart. And so the example will be find a staff by name. So for example, you can try to find me in the organizational chart. You know my name, but you really don't know where I'm gonna be at. Would be in this column, or here? Really no chance. In the sense, you really have to go through the entire organization chart to find me. In that sense, it takes longer time. Okay. And the next type is called browse, which is this one here. So you roughly know the location, but you don't know who the target is. So the example I've given here is to find the program director of the computer science department, and let's say you know this is the part of the computer science department, and then you would know the head of the department is probably this one here. Even you don't know who the person is, but you roughly know where to find the head or the program director and then find out who the person is. So in this case, you know where the information will be, but you don't know what the target is yet. That is what you want to find out. And finally, you had explore, which is this one here. In this case, and you don't know the target or the location, so that will be the most difficult one. The example I given here is to find the person with the most connections in the organization chart. Then you don't know who the person is, and you don't know where the person would be like. You have to look at the entire chart to find out which ones had the most connections. Maybe this person, which is a vice chancellor, or maybe some other ones. And so usually, and the ones when you know the location, the lookup and browse, it's relatively easier. And it's when you don't know the location and the locate and explore, it becomes much harder because the people then have to go through all the different data items in your visualization to find answers. So that will take longer time. Okay, and so that's search. So we now covered analyze and search and come to the very last part, which is called query. So again, I just want to emphasize, so these are in the kind of hierarchies. For each analyze, different types, you will need to search. You will always need search. And for each type of different searches, we look at these four, you always need query. So the query is what you do when you try to find the target. Okay, and again, so I just want to emphasize or repeat. So here you need to use the term in this particular context. So the query is very different from the query we use, say, in general conversations. And it can mean, say, a database query, like you write a SQL command, or a query you ask some questions. But here, query means quite different things. And that's what we're going to be using this term and in this module for the lecture and the coursework. Okay, and in terms of the query, and one thing you potentially do is to do identify, and you want to find something. And for example, you might want to find an outlier or the items with the biggest values, etc. So that's called identify. And most of the examples we had previously in the organization chart is like identify. So where is the vice chancellor? Who is the head of department for computer science, etc. These are all identify. Okay, and then compare, so related to multiple targets. not the single one. Identify usually a single one, but it could be more than one. In the sense, if you have an outliers, it might be more than one outlier. Okay, and the compare would be, say, again, in the previous examples, if you remember, you can try to find the person with the most connections in the organization chart. Then you look at different person and compare how many connections they have. So that's still a query, but in this case, you are not identifying because it's a little bit different, and you compare multiple. And finally, you can have summarize. In this case, you are not like any individual ones or even multiple ones. You look at everything that becomes summarized. And okay, and so here I'm gonna explain that use a different example, which is the US election results. And so this is not the data from the one which just happened. That's from the one before. I think that this is the 2016. And so here, you have the map of America, and each state is colored. It depends on whether that state is voted for the Republican or Democratic, which are the two main parties of the US. And the red ones are the Republican Party, and the blue ones are the Democrat Party. Uh, I mean, the actual names or the context is not critical, but just says if you see the red color of a state, that means it voted for the red party, and if it's green, sorry, blue, that means the party voted for, sorry, the state voted for the blue party in the election. Okay, and then in terms identify, or the kind of identify type of query, you can say the task is to identify the results for each state. So we know this is California, and that's for California, people voted for the blue party, which is Democratic. That task itself is a query and it's identify. And this is Alaska, which is somewhere here in terms of position, and it voted for Republican or the red party. So that's identify. Okay, and then in terms of compare, and you compare the results of one state to another. And so you can say, I don't know, and so you can say, okay, this is California. I don't quite know which one is this. It says Arizona. So these are having different election results because this one is red. So this one is blue and this one is red. But you can also say this states and this states and had the same color, so it's also compare. You have the same results. That's the compare. And then finally you have summarize, where you can kind of providing an overview of the results across and all different states. And you might say the west coast are mostly blue, and the middle part are mostly red, and this that will be the east-west corner. Sorry, the west, no, the northeast corner, which is this part, are mostly blue. So you're providing a general description of more than one target at the same time, and that becomes summarized. Okay. Okay, and that's where we covered and this part. And the important thing to know is that 3 levels. You first have different type of analyze, and for each analyze you have different type of search, and for each search you have different type of query. And then for analyze, we talk about different type of analyze. Either you not producing anything new or you're producing anything new. When you're not producing anything new, you have again different purposes for that. And similarly for types, for the search, we have different types, and just depends on whether you know the target or location. And finally, we talk about the query. Again, this is mostly about the number of items involved. If it only has very few, it's identify. And they have multiple ones, it will become compare. And finally, if you involve almost everything, it becomes summarize. Okay, and so that's a lot of things to understand and or to remember. And then we're going to talk a little bit more about the target. And so the target is the same as the target that we talk about here. And whether you know or unknow a target, that's the same concept of target here, which is the thing looking for. And but as you can see, the target can have many different forms, and it depends on the analysis task. You might look at different things. Okay, so the target is the part of data that's interesting to the user, and you can have 3 levels task, and something involves all the data, and you can have these trends and outliers and features. Okay, and obviously, and I guess, and trends is easier to see because that's something which involves all the data. That's quite easy to see. And outliers, and is also something involves all the data, and which is slightly more difficult to understand in the sense. I mean, you only need the answer in the end. You find out just maybe 1 or even 2 points. But you have to look at the entire data set to decide which one is outlier. Say, this point by itself does not make it an outlier. It is only become an outlier because if you look at this point and all the other points, and this one is very far away from everything else, then that becomes our outlier. And so in that sense, it still fall under this all data category. You have to look at all the data to find this. So these are probably the 2 most common ones. And then the last one is the features, which really just covers everything which is not included, is not trends of outliers. It goes under features. Okay, and here it's a bit more information about the all data targets, or the targets involve all data. And in terms of trends, you can have decrease, increase, peaks, and troughs and plateaus. So decrease peaks will be, say, something increase, and trough means something go down and then up, and then stay there, or maybe go up, and then say the plateaus is something increase and stay there, no longer increase afterwards. Okay, so this is outlier. I think here the term outliers matches quite well with what usually we will mean, and usually how we use the term outlier. So I don't think I need to explain that more. And then finally, it had the features. Here it says it's task dependent, but also just to make things a bit easier when you need to decide between these 3. Anything doesn't fit within the trends or outliers, you can just put it under features. And anything which is you looking for involves almost all the data sets, all the data points or data items from the collection you have. Okay, and the next part we're going to looking at the attribute. And if you remember, so in here, we look at all the data items or data points, and each point in the visualization is an items we mentioned early on, and usually an items would have multiple attributes. And sometimes what you're looking for is related to the attributes, and so that's where this part comes in. And sometimes you're only interested in single attributes. For example, you have a again, so go back to supermarket, the products. So the items is a product in the supermarket. You have many different products, but there's different attributes. You can have the, I don't know, the weight of the product, but you can also have, say, the profit of different product. And you can look at the values, but also you can look at either the distribution of the values or the extreme of the values. So you might want to find the lowest of values or lowest profit and of all your product. That makes sense. Or you look at the distribution of the attributes, then you look at the overall distribution. Whereas the extremes, they talk about just minimum and maximum. Okay, and you can also look at multiple attributes, and then you have some different options, and you can have dependency. So the value for the one attribute is dependent on the value of the other, and then you can have correlation, and finally similarity. So all these three can be a bit difficult they are quite similar, and the difference between them is a little bit subtle. And dependency, if from say, usually there is a causal relationship between the two attributes. And if one attribute is dependent on the other, they are definitely correlated, either negatively or positively. Let's say, and the amount of the sales and the profit is correlated in the sense, and the more you sell, the more profit you will have. Okay, but also there's a dependency between these two as well. Say, more sales can lead to more profit, but not the other way around. And if you have more profit, it's not always the result of more sales. And then the similarity, it's kind of very close. It's very similar to correlation, or we can say, or maybe similar to something like this. You can say anything that's not dependency or correlation, you can put in under similarity. Okay, and finally, we have some kind of data-specific target. So these are only the targets only exist in certain data set types. And for example, for network data, such as these ones, and you can talk about topological targets. And topological just basically means connections. So you can talk about connection-based target, something like a path. And so can be one possible target you are looking for, or you might want to look at this type of shape or this type of patterns in the network. But these are all connection-based, and they only exist in network. And again, you can look at the shape type of the shape-related target, but again, this only exists in spatial data, which is mostly just map. So this type of target and only exists in the maps. So these are what we call the data set specific targets. So in that sense, all these ones are general ones, and you can look at the trend or outliers in both network and spatial data as well as in a table type of data, whereas these targets, you only exist in network or spatial or map. Okay, and just because the time, we're gonna skip this example. It takes a long time to explain. And now then we come to the kind of summary of what we covered in this lecture. So we talked about first, there's a framework and the what, why, and how. We talked about the what last week, in terms of the different types of data and data sets. And today we cover the why, and which is the tasks you would do, the things you want to find out from the visualization, and the general ideas is when you consider these two together, that will lead to your visual design, which is actually the how. And then again, we went through lots of concepts which are related to the why, which broadly break down into these two parts. I'm sure lots of these may be still a bit confusing or doesn't make too much sense, and you will need to go back and maybe either read the book or watch the lecture again. And also by using some of these in more exercise later on would also help you to understand these concepts a little bit better. The only thing I just want to repeat now is, and in this module, we have to use these different terms in the specific context in this module. So what lookup or locate means, they have something related to do the target and locations. That's what these different terms means. And similarly for these query here, you cannot use that in the general sense as English words. Okay, and in terms of the reading, so these contents are covered in the chapter 3 of the book we mentioned, and the visual analysis and design. So if you want to read, that will be the part. So with a little bit time left, and I'm gonna do a few more slides, which is on the Tableau, showing how to do visualizations in Tableau. Let me open up the slide. Okay, and so last week we did like a kind of, I can't remember now. Yes, quick introduction of and Tableau, what you can do. And today we're gonna say a little bit more about building visualization. And so basically creating visualizations in Tableau. And so yeah, that's the interface. And yes, the last time we kind of spent a little bit of time explaining, say, this part, which is about data, which is quite important. And today we're going to talk a little bit more about in this part, which is about the visualization you created. So let's say this is mostly about the data or the what part of the data. And this is actually about the how, which we haven't quite covered yet. But the first thing you probably would notice is something called show me. And it is something, so Tableau try to guess what you want to display or visualize and generate some visualizations for you automatically. Okay. And for the beginners, it might be quite useful in the sense Tableau itself seems to have lots of functions and it can get a bit overwhelming when you try to create the particular visualization. And sometimes show me and can be quite useful in that sense. And but also uh, by using show me, there's certain things it might not do it properly, and to change it to the way you want can be a bit difficult because you don't know exactly what Tableau did to make it that way. But the most important thing is if you can select the dimensions or the actual measures that you want to display or include in the visualization, and Tableau can have a better idea of guessing what you want to produce. Okay, and so in this case, it selects the order date and cells, and then this show me, and certain optional becomes graded out, like these ones. It says doesn't quite work. For example, all the map doesn't work because Tableau detected there's no location attributes in here. You can't do a map, and then suggest some other things. And I'm gonna just show you quickly. So I'm trying to start Tableau, but seems to be. It is starting and just a little bit slow. Okay. Um, can you all see Tableau?
Yes, Professor.
Okay.
Yes, Professor.
Okay. Thank you. Oh, let me see. So I assume the text in Tableau is very small, isn't it? And can you see the text in Tableau at all?
It's not that
No,
readable.
sir.
Yeah. Okay. Let me see. That's the thing. That in the Tableau, this I have to change the system text size. Okay. Give me a minute. Let me make the text a bit bigger. Brightness, display arrangement. No, not here. Uh, no. No. That's not very useful. And okay, so what I'm gonna do is I'm gonna try to switch the display onto a different screen, and so hopefully that will make it more visible. And let me just stop this part first. New share. Let's go to this screen. Okay, and is the text a bit better now?
Yes, Professor.
Yeah, I think can you read it now? I think that's probably the largest that I can do now.
Yes, this is readable.
Okay, that's good to know. And hopefully the recording is still on. And okay, so we will talk about this like a show me. And so we're gonna using one of the dataset that comes with Tableau, and it just says sample EU Superstore. Okay, and so what you can do is uh, show me is this one here, and by default in my case, and it's disabled. But if you click, and it will shows the different validations Tableau can generate automatically for you. And currently everything is grayed out because you haven't selected what you want to display yet. And so let's say if we want to pick some options and from the data we have here, so I've collected order date and then I maybe select profit and order date, and you can see and some of these violations are no longer grayed out. So it says, okay, Tableau thinks these might be the things you want to see. It actually thinks this might be the most relevant or interesting one is the line chart. And you have other, you can do pie chart or tables or some other things. Okay, or even circles. Okay, let's just say, let's do the line chart and you double click and that's what it created for you. Okay, that's just basically what show me is. And if you don't like this, and you have to try to customize it, and that's the things we're going to cover later on. We're going to just do something very quickly. For example, and if I select the country and the location, and then it knows I want to do some visualization, which involves the location, and it's suggesting different maps. and then I choose, let's say again, profit, and you have these two options, these few options you can all do, and I think this is probably the most relevant ones. It's actually a good choice compared to the other map. There's a good reason, say, and this one is better than this. We're going to cover that later, and we'll choose, okay, that's better, so I'm going to do that. And you can see that's the visualizations it's generated for you. And so the circle represents the profit, and the size, they're located at where the countries are. Yeah. So that's show me. Let me move the visualization back on this side as well. Okay, and so you should see we are back to the slides now, isn't it?
Yes, Professor.
Yeah, okay. And so that's show me, and so that's usually where you can start. And then in next few slides, just to show different type of visualizations you can create in Tableau. We're gonna go through more examples in the lab a little bit later as well. And so you could just display data as a table, but by changing some of the colors in the table, the text color in the table, to indicate the values. For example, here it says, and the orange color means the value is true, and the gray one means false. And they say when the profit is less than 5%, it becomes orange. Okay, and you can do maps. Actually, we're already seeing that. And you can do, this is the one we just created in Tableau, like this. And this is another option. So instead of using, say, a circle or some other symbols at an area, a country or area, and you color the entire area. Okay, and maybe that's the other things we want to show you very quickly is if you want to change to different type of validations, obviously you can do the same process again, and then you choose, say this one when you do the show me. But also you can do is by changing what they call the mark, which represents which decides how do you represent each individual items. So here the mark says automatic, so that's picked as a circle. But you can actually, I think maybe shape? No. Area? No. Okay. So I thought you might be able to pick one of the markers, which will change that to the this kind of look, but it couldn't. But you can choose, instead of circle, you can choose bar. Now, a bar is used to represent the values in each country, which not ideal in this case. I think you have to choose this to move. And you can change this to line. In this case, it tried to connect all these points together. Again, not necessarily the best thing we want to do. Okay, but maybe this will be okay. And this example, and it used square instead of circles, if you can see. The circles is the default one, which is what he had before, and you can have different shapes or even just text. Okay, and it just should showing you the values, but it doesn't. Oh, okay. And so you can see here it says A, B, C, and instead of actually showing the values because it treats it as a number. Okay. And now if you choose the map, so it actually colors the region with the values instead of showing, say, previously as a circle. Okay, so that's one thing you can do. And to change the visualization, okay, And because we don't have that much of time, and maybe I just want to show you some very important. So you need to know these things. This is the other visualizations we created early on, and it shows the amount of profit over time. And we choose a line chart. Here again, you can just change the mark. You can change that to a different type. So I change to bar, it becomes the bar chart. I change to area, it shows an area chart. The only difference is the area chart, it colors the area below. Or you can use circle, then you have these points representing. Okay, and the other things you can do is, so the columns controls what displayed on the x-axis, and the rows controls what you displayed on the y-axis. And if you can see, currently on the x-axis it shows year. That means that's why it's 2017, 18, 19, and 20. And there's this little plus sign in front. For example, if you don't want to show year, but for example, you want to show quarter or months, etc., and you just click the plus button, and it will have you another thing called quarter now. So you have two. One is by year, 17, 18, 19, 20. And then for each year, it further divides into quarter 1, 2, 3, and 4. And you can keep doing this. You can further break down quarter now into months as well. And if you don't want any of these, for example, I only want a year, but not the quarter, but I want months, you can just remove this little quarter from the column. Just choose this part, a drop down, and then choose remove, which is this one here, or you can just drag it out of that column. It will also remove. For example, I just put it here. Okay, now you have an x-axis which shows a year and the values for each month. And in this case, we probably want to do it a line or maybe a bar. Okay, so that can be quite useful when you try to customize your visualization. Okay, we have a little bit time, and then maybe talk a little bit about this. So that's also quite important. As I explained before, the rows here, it means the y-axis, which is, it says profit. That's what we selected, but also by default, it shows sum. That means it's add up the total values. Okay, and sometimes it might not be what you want. Then you can quite easily change. Again, use this little drop down here. You can choose, and you can say the measurement currently is sum, and for example, you can change that to average. Then you can see the average instead of adding everything together. For example, previously it might be adding the total profit for different areas or countries. Now it's displaying an average, even though the bar may look a little bit higher, but actually you can see the values on the y-axis is actually reduced. I just go, so now it says average. If I go back to sum, you can see here it's actually 1400 in total. But if you choose the average, it's something like $70 or pound. It's much lower. And also it shows the patterns differently as well. Okay, and there's many other different measurements you can do, and the median, count, minimum, maximum, etc., or standard deviation. Okay, and okay, and so we'll probably cover this more and a little bit later on as we are running out of time. Is you have these different things here which allows you to map certain visual attributes to some data attributes. For example, you can map color, for example, into the product category. So all you need to do is just drag category and drop onto color. Okay, and you can see now each of these profit is breakdown into different category values. It shows furniture, office supply, and technology, and that's the amount of profits. And for this one, actually, it shows it's negative ones as well. Okay, and I think that's all we have time for today, and we're going to talk more about the Tableau later on and in the lab on Thursday. Okay. Thank you. I'm going to stop the recording now if I can find the control.